Right, today we're going to look at calculating the gradient of a tangent and also finding the equation of a tangent. So let's consider a function y is equal to x squared minus 4x. So we'll even just roughly sketch that. That's, going to look something like that. And what we're asked, what we're looking at is where, where are the gradients along that curve. So you can see that the curve changes, right? So let's just explore these gradients a little bit. So this whole section, you can see there has got negative gradient, all right? So gradient going down. And then this section is a positive gradient. And at a particular point, just where it changes, called the turning point, it has a gradient that's equal to 0. So those are the kind of gradients that we are expecting. Now the gradients are different, all right? So if you look at the sort of the right-hand side, here is steeper than what it is there. Right? And you can see with the parabola, as it continues to climb or move to the right, those gradients continue to get steeper. And that's reflected on the other side, but sort of negatively. All right, let's ask a question and go ahead and solve that. And we're asked, what is the gradient at x equals 1? Well, if I want to know what the gradient at x equals 1 is, I've got to differentiate this. I've got y equals, perhaps, just to keep it nice and simple, I like to use function notation. F of x is equal to x squared minus 4x. So we need the gradient function, and the gradient function is the differential. So if we differentiate that, we get 2x minus 4. Remember that 2, the power, that x squared, the 2 on that power moves out the front. You reduce the power by 1, and that 4x becomes that. So this is your gradient function, also called the differential, gradient function differential. Two words really mean the same thing. Now, to find out what the gradient is at x equals 1, I need to substitute that 1 into the gradient function. So if I do that, I get 2 times 1 minus 4, and therefore that's equal to negative 2. So the gradient at x equals 1 is negative 2. And so that's somewhere sort of along here, say, and we've got this thing over here. Now what I've drawn here too, this is the, let's move back here a little bit. This is the tangent line. And the tangent, it touches at a particular point on the curve without crossing it. So it sort of glances that curve. There's only one unique tangent for every point. And what we've done is we've calculated the gradient of that tangent. So we could say, what is the gradient of the tangent at x equals 1? Right, so that is interchangeable. What is the gradient of the curve? Okay, so let's just add that in, of the curve at x equals 1, or of the tangent to the curve at x equals 1. So either way of expressing that are really the same. And often we write what we wrote, what is the gradient at x equals 1? We know it's the curve x squared minus 4x, but that's it there. So when you're looking at a lot of the textbooks, they'll be talking about tangent to the curve and the equation of the tangent of the curve and the gradient of the tangent to the curve, and that's what we're talking about. So just draw that again. So if I've got some curve like that, there's a point, so we can say, what is the gradient at that point? Well, the gradient at that point is the same as the gradient of the tangent. So if this was m is equal to 2, that says m is equal to 2. That's just the same thing. So by definition, we should talk about the tangent at the point. And so the gradient of the tangent at the point, but that'll get shortened down to what is the gradient at that point. All right, so there we go. We've worked out what is the gradient at x equals 1, but what about some other points? Okay, so what is the gradient of the tangent to the curve at x equals 0? Okay, well, we've got this function f of x is equal to 2x minus 4, at least the differential now. We substitute 0 into that. So 2 times 0 minus 4, and we get negative 4. It kind of makes sense because, you know, if this was 1 here and 0 is there, and I'll draw the tangent in a different color this time, then you can see here that tangent is at a different point at x equals 0. Okay, so that's what you do. What's the process? Let's just have a look at that. The process is 1, differentiate, 2, substitute, sub in x. Okay, and there it is. There's my gradient. So only 2 things to do: differentiate, sub in x. Perhaps just try one more just to be, in fact, you try this one. Okay, so this is for you. What is the gradient at x equals 3 for the curve y equals 3x squared minus 5x? All right, pause the video, give this a go, and then come back when you're done. Here we go. So f of x is equal to, I'm just writing it out again, just using function notation. Makes it tidier when we substitute things in. Right, 1, differentiate. So I get 6x minus 5, 2, substitute, put 3 in there, 6 times 3, oops, that's 18 minus 5, and you get a gradient of 13. So you can even write m is equal to 13 for gradient, or we just leave it as 13. And we're done. Right, next thing is go back to the function that we started with, all right? So here we've got f of x is equal to x squared minus 4x, all right? So what I want to know is that when is the gradient equal to 0? So different question. So what we're doing now is we need to work backwards a little bit. So we're given a gradient and we need to work with that when. That when is usually some kind of coordinate. It could mean x or a coordinate. So I've been a little bit vague by saying when. And in fact, when is sort of the wrong thing. It should probably be where. So where is the gradient? Because it's a location. Where is the gradient equal to 0? In other words, what x value or what coordinate? So we'll go ahead and find the x value because we need to do that anyway. And then we'll have a look at that, the full coordinate of where that is. Okay, where is that gradient equal to 0? We'll just go back and have a quick look. So where is it 0? Well, we saw, getting messy, eh? But we saw that that's at that point there. All right, so there's my gradient is equal to 0. Well, what x value is that likely to be? Well, looks like it might be x is equal to 2. But let's go and use calculus to make sure that we're right. Right, so we still need to differentiate. Okay, so 1, differentiate 2x minus 4. Okay, so we've done that. Now I take this function and I set it equal to 0 because that's the gradient function now that we've got. So in other words, to work out the x value, I need to set that equal to 0. And you can see pretty quickly that I get 2x is equal to 4, and divide by 2x is equal to 2. So that answers the question, where is the gradient 0? Well, it is 0 when x is equal to 2. So we've answered the question, but let's break that down a little bit again. And so what do we do? 1, differentiate. 2, we set the differential equal to 0. And 3, we solve. Now, if I also want the y-coordinate, we've got to be careful because we need to go back to the original function, this thing over here, okay, x squared minus 4x. In other words, what's the y value? What's the y value at that point? We've determined that that's 2, but what's the y value there? Well, to do that, we need to substitute x equals 2 back into the original function. So the original function is x squared minus 4x. So that's the next thing is really we 4 sub x equals 2 into f of x, which is the original function, to finish that off. So f of x is equal to x squared minus 4, I think that's what it was, wasn't it? No, minus 4x. And we put 2 into that, so we substitute 2 in. 2 squared is 4, and that's minus 8, right? And therefore we get negative 4. So the full coordinate, that's my y coordinate now. So the coordinate then is 2 and negative 4. Right, just a recap. Yeah, let's just quickly recap before we move on. Okay, so we're talking about gradients. Remember, to calculate a gradient of a curve, we need a differential. All right, so if we look at this problem over here, you can see there, point 1, we differentiate and we sub it, and that will give us a gradient. So whether it's a tangent or whether we're just asked to find the gradient, it's the same thing, remember. 1, differentiate, 2, sub in x, out pops the gradient, we're done. So relatively simple process, only involving 2 steps, differentiate, substitute. The next thing though is finding x values for particular gradients. All right, so this is the second thing that we're looking at here. So we still differentiate, so we differentiated it. But because we're after when is the gradient 0, all right, so careful here. So it's not always 0, it depends on what the gradient is. If I wanted to work out when's the gradient 5, I put 5 in there. So I got 2x minus 4 is equal to 0. We substitute that in, and well, we set it equal to the gradient that we want, which is 0. We go ahead and solve it. I get x is equal to 2. Yeah, so that's the x coordinate when the gradient is 0. The next thing is, what about the y coordinate? If we're asked for that as well, then we sub back into the original function. Okay, and that's important, that it's back into this one there, not the differential, okay, not the gradient function. And that's that one. Let's just do one more example. Yeah, here we go. Perhaps you try this one. Let's say I've got y is equal to 3x squared minus 2x. And the question is when or where. Let's use where. Let's fix that up. All right. Where is, oh, that's there we go. Where is the gradient equal to 1? All right, so we're not using 0 this time, but we're saying when's the gradient equal to 1? All right, give that a go. Remember the process. 1, differentiate, set the differential equal to 1, solve it, and then substitute that solution back into the original function to work out y. So go and do that now. Pause your video and then come back when you're ready. Here we go. So let's differentiate. In fact, just to be, let's stick with that. All right. So we're going to put y prime 6x minus 2. All right. Set that equal to 1. Okay, fantastic. And then I get 6x is equal to 3 by adding to both sides. And if I divide through by both sides, x is equal to 1/2. All right. So that's really, that's it. We're done. We're done there. So when is that equal to 1? Well, when x is equal to 1/2. If you want to, all right, and we will ask for the y coordinate, then we can do that as well by putting that back into the original function. So what is the y coordinate? 3 times 1/2 squared. Notice I'm going back into that one there. Minus 2 times 1/2. And that's 3/4 minus 1. And I think that's -1/4. Right, last thing to do, and that is equation of a tangent. All right, equation of a tangent. So here we go. Let's say, what is the equation of the tangent to y equals x squared minus 4x at x equals 1. Right, a little bit different because now we're after the equation of the tangent. We're not after the gradient of the tangent, but the equation of the tangent. And remember, because the tangent is a line, it has a line in the form of y equals, has an equation in the form of y equals mx plus c. Right, so let's give that a crack. What do we do? Well, if I want the equation of a line, then I need a gradient, m, and I need a y-intercept, c. And really it's just a matter of filling in the blanks to get that done. So I do need a gradient. And this is where calculus comes in useful, because calculus has a lot to do with calculating gradients. So we'll go ahead and differentiate. So 2x minus 4. Okay, so there's my differential. I differentiated it. Then I substitute in x equals 1. So I'm just going to write m straight away. M is equal to 2 times 1 minus 4. And I get a gradient of negative 2. All right, there we go. We've done that. And so now that I've got my gradient of -2, so let's just stop and think about what have we done? What have we done? We have 1, differentiated it, 2, sub in x equals 1, and we've got our gradient. But we still need we need to continue to work out the we need the full equation of the line. So I've got this so far. I've got m is equal to that. Now what I need is to be able to work that out. I need a point and a gradient. Okay, so I said we would need to work out the intercept, but we may not be able to get that. So going back to the work on coordinate geometry, we use this equation: y minus y1 is equal to m x minus x1. Okay, so if you don't know that one, there it is there. That's what we need. Right, now I need it at x equals 1. So a little bit trickier is that I need to work out what is y at x equals 1. Okay, but I have to go back to my original equation, which is this one over here. All right, so remember, I need a point. And what is y when x is equal to 1? Okay, so m I've got, done that, but I need x1, y1 is what I need. So at x equals 1, we'll just substitute 1 into the equation. Y is equal to 1 squared minus 4 times 1. Well, 1 squared is 1, and 1 minus 3 is negative 3. So I've got that. Okay, so I've found this point now. So this is 1 and negative 3. Okay, so we're ready now to substitute into that equation that we're given here. So there's my nice equation ready to substitute in. So y minus negative 3. M we worked out as negative 2. Okay, here's m. Negative 2. And then x minus 1. Okay, so substitute it in, and from there we can go ahead and create the equation. Well, first of all, let's y equals 3, negative 2x plus 2. And then last thing to do, subtract 3 from both sides. Y is equal to negative 2x minus 1. And that's the equation of the tangent at that point. And this time we are done. Let's have a look then, just at this whole question again, to work out what are we doing. Okay, we want the equation of a tangent. So the equation of a tangent is a line in that kind of form, y equals mx plus c. So here's the question: what is the equation of the tangent to y equals x squared minus 4x at x equals 1? We differentiate, done. 2, we substitute in x equals 1 to calculate the gradient. So there we are, we've got a gradient. Using the equation y minus y1 is equal to mx minus x1, having a gradient, I need a point. I need a point on the tangent. And the point on the tangent has to be, if we go right back up to start there, all right, and we've got a tangent there, it needs to be a point that's right on that tangent. So if it's there, or wherever it is. But I need that point on the tangent, which is also the point on the curve, right? So it's also the point on the curve. So because we were given, okay, look at that, we were given x equals 1, we substitute x equals 1 into the original equation. And that's what we do to get that point, this point here, x1, y1. So when we put 1 into the equation, 1 squared minus 4 times 1 is negative 3. And that gives us that coordinate here, which is 1 and negative 3. So we can finish this off by substituting all of that into here, which is what we've done. So y1 is equal to negative 3. So I get y minus negative 3, my gradient, negative 2. And then there's my x value there. And from there we go ahead and solve that. And that's plenty of stuff for now.